confined to theoretical physics, labs they are already shaping industries, technologies, and even our daily lives. From revolutionary medical imaging and energy solutions to quantum navigation and unbreakable cryptography, quantum mechanics is poised to transform every aspect of society. The future is quantum, and as we continue to unlock the mysteries of the quantum world, the possibilities are endless. Whether in health, energy, security, or computing, quantum mechanics promises a future where science fiction becomes science fact. As we continue to explore and harness these extraordinary technologies, we may be on the brink of a new era of innovation that will change the world forever. The quantum journey ahead. Quantum mechanics has taken us on a journey through the very fabric of reality itself, a realm where the familiar laws of physics are challenged and the impossible becomes possible. From the mind-bending properties of wave-particle duality to the profound questions it raises about time, consciousness, and our understanding of existence, quantum science pushes the boundaries of human knowledge and invites us to think in ways we never have before. We've explored how quantum mechanics is reshaping not only physics but philosophy, asking whether reality exists only when observed, and whether every possible choice creates a new universe. We've delved into the potential connections between quantum processes and consciousness, raising the possibility that the universe itself could possess a form of awareness. We've seen that quantum mechanics isn't just abstract theory, it's already changing the world in concrete ways. Quantum computing promises to revolutionize industries by solving problems that are currently beyond our reach. Quantum cryptography is set to make communication more secure than ever before. Quantum sensors and energy solutions could transform healthcare, navigation, and our global energy systems. The future of quantum science is a thrilling one. While there is still much to learn, the breakthroughs we've discussed could reshape entire industries, solve some of the world's most pressing problems, and open up new frontiers in technology and human potential. As quantum technologies continue to evolve, we are standing on the brink of a new era, an era where the strange, wonderful, and mysterious world of quantum mechanics becomes an integral part of our everyday lives. But perhaps the most important takeaway is this: quantum mechanics teaches us that the universe is far more interconnected, unpredictable, and beautiful than we ever imagined. Whether we're trying to unlock the secrets of consciousness or exploring new technologies, quantum science reminds us that there is still so much more to discover. We are only beginning to scratch the surface, and the future holds infinite possibilities.
Look up at the night sky. What do you see? Stars scattered like specks of dust, galaxies stretching across the void, planets orbiting distant suns. But beyond the beauty, beyond the spectacle, lies a question that has haunted human consciousness for millennia. Does the universe have a purpose? Is everything we see, the grand expanse of space, the delicate balance of life, the rise and fall of civilizations, part of some larger design? Or is it all just a cosmic accident, a meaningless swirl of matter governed only by chance and the cold laws of physics? If the universe does have a purpose, what is it? And if it doesn't, what does that say about our existence, our struggles, our dreams? This is a question that transcends science and philosophy. It is one that poets, theologians, physicists, and philosophers have debated for centuries. Some argue that the universe is finely tuned, designed with a precise order that suggests intentionality, perhaps by a divine creator, or perhaps by some unknown intelligence beyond our comprehension. Others believe that life, consciousness, and human existence are nothing more than fleeting anomalies in a vast and indifferent cosmos, doomed to be erased by the relentless march of entropy. Then there are those who take a different approach, who suggest that regardless of whether or not the universe has an inherent purpose, we have the power to create our own meaning. If no external force has imposed significance upon our existence, then perhaps that very absence of purpose grants us the ultimate freedom, the ability to shape our own destinies, to define what matters, and to find beauty in the vast, empty expanse. In this exploration, we will examine four major perspectives. 1. The nihilistic view, the belief that the universe is devoid of meaning, that existence is random, and that any sense of purpose is a human illusion. 2. The teleological view, the argument that the universe is not an accident, but a finely tuned system with an inherent goal or purpose, whether divine or natural. 3. The existentialist view, the idea that while the universe may not have a given purpose, we have the freedom and the responsibility to create our own meaning. 4. The multiversal perspective, the notion that if multiple or infinite universes exist, then purpose itself may be contextual, varying from one reality to another. Through these lenses, we will confront the greatest mysteries of existence. We will dive into the depths of cosmology, explore the philosophy of meaning, and challenge the very foundations of our understanding of reality. But before we begin, consider this. If the universe has no purpose, does that make it meaningless? Or does it make our role even more significant? If purpose does exist, is it something? One of the greatest psychological biases humans have is pattern recognition. We see faces in the clouds, meaning in coincidences, narratives in randomness. We want to believe that structure implies design, that the complexity of life and the universe must mean something. But this is a fallacy. A sand dune, sculpted by the wind, can look like a masterpiece, yet no artist. But whether we can find meaning despite its absence. But before we can explore that, we must consider another possibility. What if the universe isn't an accident at all? From the moment we are born, we are conditioned to believe that life has meaning. We are told that hard work leads to fulfillment, that love is sacred, that justice prevails, that our existence emerges. The universe seems perfectly set up for life to exist. Change even the slightest detail and everything collapses. There are certain fundamental constants that govern our reality, values embedded in the fabric of the universe itself. These constants define how forces interact, how atoms form, how stars burn, and ultimately whether life can arise at all. If these values were even slightly different, life as we know it, and possibly life of any kind, would be impossible. Here are just a few examples of how fine-tuned the universe really is. The strength of gravity. Gravity is the force that binds planets, stars, and galaxies together. It governs the formation of cosmic structures, and without it, the universe would be an empty void. If gravity were slightly weaker, matter would never have clumped together to form stars or planets. The universe would remain a thin, lifeless gas, drifting aimlessly through space. If gravity were slightly stronger, stars would burn through their fuel too quickly, collapsing into black holes before life had a chance to develop. The difference required to tip the balance? A change of just one part in 10 to the power of 36, a fraction. So small, it is almost incomprehensible. To put it in perspective, imagine adjusting the weight of the entire Earth by less than the mass of a single proton, and that being enough to make the universe completely uninhabitable. The expansion rate of the universe. The universe has been expanding ever since the Big Bang. The rate of this expansion is dictated by a number known as the cosmological constant, a force that counteracts gravity and determines how quickly space stretches. If the expansion rate was slightly faster, galaxies, stars, and planets could never have formed. Matter would have been flung apart too quickly. If the expansion rate was slightly slower, the universe would have collapsed back into itself in a big crunch before life had time to evolve. The margin for error? 1 part in 10 raised to the 120th. That is a level of precision beyond comprehension. It is like hitting a single specific atom with a dart, blindfolded, from across the observable universe, and getting it right on the first try. The balance between matter and antimatter. When the universe was born, it contained nearly equal amounts of matter and antimatter. But had they been created in exactly equal amounts, they would have annihilated each other completely, leaving behind a universe of pure energy, with no atoms, no planets, no life. And yet, for some reason, matter slightly outnumbered antimatter, just enough for the physical universe to exist. This imbalance was incredibly small, about 1 extra particle of matter for every billion particles of antimatter. If this ratio had been any different, the universe would be either a lifeless sea of radiation if antimatter had won the battle, a dense collapsed singularity if matter had overwhelmed antimatter by too much. But somehow the perfect balance was struck, allowing a physical universe to form. Coincidence or design? Taken individually, each of these parameters being perfectly set for life might be dismissed as a coincidence, but when you stack them together, gravity, expansion rate, the balance of matter, nuclear forces, the properties of water, the stability of atoms, the fine-tuning of our solar system, the improbability reaches absurd levels. It is as if the universe were calibrated with life in mind, as if some unseen force had adjusted every dial, every constant, every equation to create conditions just right for consciousness to emerge. This has led some scientists and philosophers to argue that the universe is not a random accident, but a system built with purpose, whether by a divine creator, an advanced intelligence, or some principle of cosmic design we have yet to understand. But if that is the case, what is that purpose? And if the universe was designed for life, why is it so hostile to life in most places? Despite its appeal, the fine-tuning argument has its critics. Some argue that it is merely an illusion, that what seems like precision design is just one outcome among many possibilities. The anthropic principle. We observe a universe fine-tuned for life because we are here to observe it. If conditions had been different, we simply wouldn't exist to notice. This does not prove purpose. It only means that we happen to be in a universe where life is possible. The multiverse hypothesis. Some physicists suggest that our universe is just one of an infinite number of universes. If there are countless universes with different physical laws, then it is not surprising that at least one of them would be finely tuned for life. In this view, our universe is not special, it is merely one of many, and we exist in it because we happen to be in one where life is possible. Unknown natural laws. Perhaps these fine-tuned constants are not arbitrary, but the result of some deeper principle of physics that we have yet to discover. If this is the case, then the universe was never fine-tuned. It simply follows laws we do not yet understand. So is fine-tuning evidence of deliberate design, or just the inevitable outcome of probability and physics? The question remains open. But if the fine-tuning argument holds any weight, then it implies that the universe is not an accident, that something or someone set the parameters of reality with intent. And if that is true, then what does it say about our role within it? Are we simply bystanders in a grand design, or are we active participants in a greater cosmic purpose? To explore this further, we must dive deeper into the philosophical and theological implications of a deliberate universe. If the universe is fine-tuned for life, then a fundamental question arises: why? Is it purely a cosmic coincidence, a product of blind physical laws operating with no intent, or does fine-tuning suggest something deeper, something intentional, a universe built with a goal in mind? For thousands of years, philosophers, theologians, and scientists have grappled with this question. Some argue that the sheer improbability of life points to an intelligent designer, whether that be a divine being, a cosmic architect, or an unknown force shaping reality from the shadows. Others suggest that purpose is a human projection, an illusion we impose on a universe that, in truth, is indifferent to our existence. To understand this debate, we must examine two key perspectives. 1. Religious interpretations. The universe as a creation of God or higher intelligence. 2. Philosophical theories. Purpose as a fundamental or emergent property of reality. Let's begin where humanity has always sought meaning: religion. For millennia, civilizations across the world have looked at the stars and seen the hand of a creator. In nearly every major religious tradition, the universe is not an accident. It is an intentional construct, designed by a higher power with meaning, order, and purpose. Here are how some of the world's major religious traditions interpret the teleological question. The monotheistic view: creation by an intelligent designer. In Christianity, Islam, and Judaism, the universe is the deliberate creation of a single all-powerful God. The book of Genesis states that, in the beginning, God created the heavens and the earth, suggesting a conscious
proposed that studying the multiverse might reveal whether the Big Bang was a singular event or just one of countless beginnings in an endless cycle of cosmic creation. Then there's the technological potential. If we could somehow harness the principles of parallel universes, like the mysterious connections hinted at by quantum mechanics, imagine what might be possible. Could we use those principles to solve problems we've never been able to solve before, like faster-than-light travel, infinite energy sources, or even new ways to explore the cosmos? But perhaps the greatest discoveries would come not from the differences between universes, but from what they share. By studying the multiverse, we might uncover universal truths, patterns, or principles that apply across every reality.
If hyperdimensional intelligence exists, why haven't they revealed themselves openly? Some researchers suggest structures. The moment we confirm non-human intelligence exists, everything changes. For centuries, religions have provided answers to humanity's deepest questions. Who are we? Why are we here? What happens after we die? But if an advanced civilization appears, one that has mastered time, space, and perhaps even consciousness itself, then where does that lead? Random fluctuation is not a destiny. Even with randomness, the universe remains a system without intent, unfolding without guidance, without agency, without anything resembling a goal. One of the greatest psychological biases humans have is pattern recognition. We see faces in the clouds. Life is possible. Unknown natural laws. Perhaps these fine-tuned constants are not arbitrary, but the result of some deeper principle of physics that we have yet to discover. Physicist Hugh Everett proposed a radical idea known as the many worlds interpretation. He suggested that whenever a quantum event occurs, whenever a particle has to choose between different states, the universe splits. Each possible outcome happens, but in a different branch of reality. Think of it like this: you're standing at a crossroads, deciding whether to turn left or right. Easily have been yours. Here's the ethical dilemma: would you have? Then there's the technological potential. If we could somehow harness the principles of parallel universes. Physicists have long theorized that our universe isn't just three-dimensional. String theory, one of the most promising models in modern physics, suggests that reality may contain up to 11 dimensions, far beyond what we can comprehend. If advanced beings have evolved to perceive and navigate these higher dimensions, they might be able to pass through our world unseen, just as we can move through a 2D space without being noticed, manipulate reality in ways that seem supernatural, like appearing and disappearing or altering time itself, observe us freely while remaining completely invisible to our senses. Could it be that some of the UFO sightings, paranormal experiences, or unexplained phenomena we've recorded throughout history are glimpses of beings moving through higher dimensions? This isn't just a thought experiment. Beyond anything we imagined, spiritual awakenings could transform how we understand existence. A unified humanity might emerge, realizing we are part of a greater cosmic community. Could this be the next
physics, labs, they are already shaping industries, technologies, and even our daily lives. From revolutionary medical imaging and energy solutions to quantum navigation and unbreakable cryptography, quantum mechanics is poised to transform.
If the nihilistic perspective is correct, then the universe is nothing more than an accidental byproduct of natural laws, unfolding without intent or direction. But what if that assumption is wrong? What if the universe is not a chaotic accident but a carefully calibrated system, where the fundamental forces of nature are precisely balanced in a way that allows life and consciousness to emerge? This is the foundation of the fine-tuning argument, one of the most compelling reasons to believe that the universe is not just a meaningless expanse of matter, but a deliberate construct designed, or at least structured, in a way that suggests purpose. Because when we look at the fundamental constants of physics, an eerie truth emerges: the universe seems perfectly set up for life to exist. Change even the slightest detail and everything collapses. There are certain fundamental constants that govern our reality, values embedded in the fabric of the universe itself. These constants define how forces interact, how atoms form, how stars burn, and ultimately whether life can arise at all. If these values were even slightly,
it could have left a detectable mark in the CMB. Imagine two soap bubbles colliding. The point of contact creates a ripple. Similarly, a collision between universes might have left imprints in the fabric of space-time that we could still see today. So far, no conclusive evidence of such collisions has been found, but that hasn't stopped scientists from looking. Telescopes like the Planck satellite have mapped the CMB in exquisite detail, searching for anomalies that could hint at a multiverse. Another area of exploration comes from the distribution of matter in the universe. If parallel universes exist, they might subtly influence how galaxies are arranged on the largest scales. Some researchers have suggested that strange alignments or patterns in the cosmos could be the result of interactions with other universes. And then there's the concept of quantum fluctuations. These tiny variations in energy, present during the inflationary period, could have seeded the creation of not just galaxies but entire universes. Observing these fluctuations and understanding their role might provide further clues about the multiverse. But here's the challenge: proving the existence of other universes is incredibly difficult. By definition, these universes exist outside our own, beyond the boundaries of what we can directly observe. It's like trying to see the other side of a wall when you're locked in a room. Still, the search continues. Scientists are pushing the limits of technology and theory, probing deeper into the origins of our universe. Every discovery brings us closer to understanding whether we're part of a multiverse, or whether our universe stands alone in the vast expanse of reality. So, could the answers be hidden in the light from the earliest moments of creation? Or will the multiverse remain forever a tantalizing mystery, just out of reach? Now, let's step away from the theories for a moment and dive into something more imaginative. What would it actually be like to live in a parallel universe? Could it feel similar to our own reality, or would it be so different that we wouldn't even of reality? It's humbling to imagine that our universe might be just one small piece of an endless multiverse, and yet it's exhilarating to know that we're part of something so immense, so mysterious, and so beautiful. And perhaps, whether or not we ever find proof of other realities, the most important discovery might be what this exploration teaches us about ourselves, about our place in the cosmos, about the choices we make, and about the boundless curiosity that drives us to keep asking, keep searching, and keep wondering. So, as we close this journey, consider this: in a universe so full of mystery, where every possibility could exist somewhere, what does that mean for the choices you make today? What does it mean for how you see yourself, your world, and the infinite unknown? The answers may lie beyond our reach, but the questions will always push us forward. So, as you step back into your own universe, carry this thought with you: every question we ask, every possibility we imagine, brings us closer to understanding the extraordinary reality
exist in higher dimensions, just beyond the reach of human perception. This isn't just wild speculation. The idea that higher dimensional life forms could exist is deeply rooted in theoretical physics, string theory, and even quantum mechanics, and if they do exist, it could explain some of the most perplexing mysteries about the universe and why we haven't found extraterrestrials yet. Imagine a world of flatlanders, intelligent beings who live in a two-dimensional plane, like ink drawings on a sheet of paper. They can move left and right, forward and backward.